Okay, in this video we're making sure that we know how to solve quadratic equations using the quadratic formula. There may be other techniques that will work for these, but quadratic formula works for any quadratic equation. So I'm not going to bother seeing it as factorable or bother with completing the square. I'll just jump right into using the quadratic formula. The quadratic formula says that x is going to be equal to a very large fraction where the top of it starts with the opposite of b. So b here is -7, so positive 7, plus or minus the square root of a lot of stuff. Inside that square root, there's going to be b squared, and I'm just reading off the formula here. So -7 squared is 49. I'll do that calculation in my head. Minus 4 times a times c. Well, a in this case is 1, and c is -10. So I'll just write those numbers in. Clean that up just a little bit. And then on the bottom, it's 2 times a. Well, 2 times a is, well, since a is 1, 2 times 1 is 2. So I've just written in all the stuff there. Haven't done much calculation. Now I'll simplify it. And we'll calculate what's 49 minus -40. Well, that's the same thing as 49 plus 40. So 89 all over 2. Now the last thing I'm going to check is 89, square root 89, something that can be simplified, and it doesn't divide by 2 or 3 or 5, nor 7, nor 11. So this thing's prime, so we're done with this thing. If you need to have decimal answers, no problem, calculate them. 7 plus whatever the decimal value of root 89 is, get an answer, divide that by 2, there's your first decimal answer, and then 7 minus whatever the decimal value of root 89 is, get an answer, divide that by 2, and there are your decimals. I wasn't asked to put this in decimal value, so I'm just going to leave it alone. On the next one, I'm still solving using the quadratic formula, but I see a little bit of a problem first. I'm supposed to have the equation in the form ax squared plus bx plus c equals 0. Well, I don't yet. I've got stuff over here. And so what I'm going to do is get rid of these things first so I have 0 on this side, and then I can use the quadratic formula. So I'm going to get rid of this. Have some room here. And I'm going to add 2x to both sides. And of course the only thing I can add 2x to over here is right here. And I'm going to subtract 2 from both sides. So I'll just do that all together. This gets me 2x squared minus 5x plus 12 equals 0. Everything else on purpose went away. So now I've got my values of a, b, and c here. Let's take care of that. X equals big fraction, the opposite of b, so positive 5, plus or minus the square root of b squared, that's going to be 25, minus 4 times a times c. Okay, so I'm just substituting those values in, and then down below it's going to be 2 times a, so 4. All right, so I've got that. We'll do a quick little calculation here. 4 times 2 times 12 is going to be 96. Okay. Well, 25 minus 96, we've got a bit of a problem. Let's make sure we have the right answer on that. 25 minus 4 times 2 times 12. It's -71. Shoot. Well, how do we deal with a -71 in there? There are no real numbers that you can use to square and get -71. Well, in other videos, other lessons, you've seen how to simplify that using non-real numbers. That'd be the same thing right there. We just kind of have to wink and nod and pretend that this thing actually exists, and it does. It's just not a real number. And what we've done is called that value I for the imaginary number. So your answer is going to end up being 5 plus or minus I root 71 all over 4. So there's both your answers. They are non-real solutions, but they're still solutions. So the short and sweet on that one is when you get a negative inside the square root sign, just replace it with an I outside the square root sign. Write the rest of it and go on with your life.